Hi everyone, welcome to Operations Management course. In this lecture, we will learn Statistical Process Control Chart. Look at overview of the course. We have learned operations and productivity and OM strategy and quality. Then now we are on Statistical Process Control Chart. After this, there will be an exam that covers these 4 chapters. We'll talk about 3 topics. The first one is the significance of a statistical process control chart. And the second topic is the content of SPC. And the third topic is mean and range charts. Let me introduce Walter A. Short to you. Short brought together the disciplines of statistics, engineering, and economics and became known as the father of modern quality control. He is most widely known for the control chart, a simple but highly effective tool that represented an initial step toward what he called the formulation of a scientific basis for securing economic control. The single reason that we need SPC is because it enables us to check the reliability of a process. Whether it is a production or service setting, we want to understand whether the product being manufactured or service being served is meeting the product specification. Statistical process control does the job because it samples a number of products and investigates whether a product remains in the predetermined set of specifications. Changes in shift, materials, equipment, and people also make it necessary for checking the process accuracy and stability. So SPC enables us to check the stability of a process by looking at the distributions. The advantages of statistical process control chart is it helps us to monitor the process and correct the process and improve the process. The second topic that we will discuss is the content of SPC. To do so, let's take a look at the sources of variance. SPC is a quality management tool to distinguish between natural variations and variations due to assignable causes. Variability always exists in a process. Think of taking a course. Some students come early, some other students come on time, and still other students come late. An instructor expects it to happen. However, say one day the majority of students did not come on time. It's an unusual case, and one can suspect that something happened, something unusual happened, such as traffic accident and inclement weather. These are assignable causes. Natural or common causes affect virtually all production or service processes, whereas assignable causes can be generally traced to specific causes. The objective is to discover when assignable causes are present and when we can eliminate the bad causes and incorporate the good causes. Let me also talk about mean and range. We discussed that variance can be divided into natural cause and assignable cause. In examining variance, we also need to look at 2 types of data. The first one is mean data, and the second is range data. Looking at averages does not convey the whole picture to the operations manager. We also need to look at range data and let us see why that is the case. Say, here we have 2 students. They took 3 classes. Student A received an A and B and C from 3 courses respectively. However, student B received all Bs. So both GPA is the same, say 3.0. As an HR person, it might be difficult to decide which student is better and fit for the job. That's why we need to look at the variation too between these 2 students in terms of their GPA. When you look at the standard deviation, here we see that student B has a 0 variance because out of all 3 courses he got all B's, so there's no variation, which means this person is a B-level student and very consistent person. However, student A does have a variance. Now, which student would you like to hire? It depends on what kind of student you are looking at. If you are looking at the consistency, you might go with the student B. But if you want to hire a student who has a very good knowledge about operations, you might want to hire student A. The point here is that looking at mean is not enough, and you have to look at range as well. These figures are the graphical explanation about mean and range charts. When a process is shifting upward, but range is consistent, look at here, so the process is shifting upward, however, the range, the difference between the maximum and minimum, is steady. So if you draw this one as a statistical process control chart, then you will see X bar chart is shifting upward because the mean is shifting upward. However, R chart is staying the same because the range is constant. Now, another case is this. In contrast, in these figures, sampling means is constant, but dispersion is increasing gradually. So the mean is steady, however, the dispersion is increasing more and more like that. Therefore, if you draw that on X bar chart and R chart, you will see similar pattern. X bar chart is the same, however, R chart is increasing. Therefore, this one especially is out of the boundary. So therefore, this is out of control. The lesson to take from these examples is that both X bar chart and R chart have to be under control to conclude that the process is under control. Even if they are under control, we have to look at the patterns of these dots so that we can make a correct judgment. So in this part, we learned the significance of statistical process control. It enables us to visualize the process and see what is happening. And as a result, we can monitor, correct, and improve the process. And the second topic we learned was the content of statistical process control. And it's about variation. There are 2 variables, variance. First variance is assignable variance, and the second one is unassignable variance. And we are particularly interested in assignable variance. We also learned that we need to pay attention to mean and range together. Thank you.